Good evening, friends. Hope my voice is clear. So today we'll continue with the trade analytics, and we are going to see one of the supervised classification model. So that is helping to analyze or predict the company stock, where you'll be having some 2019 to 2022 August. So we are July, you'll be having. So we are just predicting for the next month. So we are considering some portion of the data and then dealing with the prediction of that particular company. So far we have seen the day one application of machine learning and AI in the trading analytics. And the second day we have seen the CRISP MLQ, which is important for project management methodology and exploratory data analysis. So next day we have seen clustering algorithm, that is k-means algorithm. So next we have come across a classification model. So classification model is KNN. So we have seen, and then we started understanding about the regression model. So where we have used linear regression model, and that we have seen yesterday. So today, so we'll again use classification model. So which is nothing but the decision tree. So we are considering today with respect to decision tree. So we have already learned k nearest neighbor, which is considering the nearest neighbor and calculating the distance and then grouping it. So here the decision tree is based on greedy algorithm. Greedy algorithm. So where you'll be having a root node, and you'll be having a branch node, and you'll be having a leaf node, and you'll be having different level. So this is level 0, this is level 1, and this is level 2. So once you reach the leaf node, that will be your end of the trace. Let's say example, employee, which is having a greater than salary 50,000. Yes means left side, no means towards the right side. So the company, the salary having 50,000 greater than is manager. If yes means it will come here. If no, it will go here. If he is taking 50,000 and he is a manager, he'll be a technical lead. If he is a manager, he's going to buy a new house. So my prediction is, if is whatever the salary that they have greater than 50,000, they are going to buy a house. See, this technique, decision tree, what we have mentioned is under classification problem, because we have a categories. So we have a categories, either going to buy a house or not buy a house. So these are the two categories that they can do it. Based on this will be chosen based on different criteria, different conditions. So there will be more criteria to lead and land up with saying they are buying or not buying. So when we have more criteria, more conditions, then you'll be using decision tree. So here also in trade analytics, the company stock. So we are just predicting whether it is increasing or decreasing in next few days based on the past history. So everything will be past history. So you'll be having past history for data decision tree. So let's say example, we have a data and in this you will be having a output saying that either you play or no play based on different data. Let's say example, if it is too sunny, too windy and too breezy, cool is wind is very cool, and we'll say no play. Now when I'm saying no play, which is more important? Which feature is making more important? So we need to understand the dependency variable, which is play or no play, will be dependent on all these features. But there should be some variable which is giving more preference. So first, second, third, and fourth. So how do you decide which is the first one or which is the most important factor which is dependent by dependency variable? Let's say example, I've showed you one example that if the salary is greater than 50,000, they are going to buy a house. So let it be a manager, let it be an employee who is not a manager and is a TL. So like this, you will be having several criteria and conditions that will be here, but which criteria and which condition is impacting the output is more important. So choosing this appropriate parameter will give you more information. Choosing this appropriate will get you appropriate decision. So when you are planning to make decisions with more constraints, leading to a decision, we'll go for decision tree. So that is the basic idea scenario where you'll be. Now, my question is, how do you choose this parameter? On what basis you select which is first, which is second, which is third, which is fourth? So we have entropy calculation. And we have information gain. And later we'll have gain of that particular value. So we'll try to understand from the problem and then we'll go into the trade analytics. So when it comes to decision tree, so decision tree is going to understand with the tree-like structure. So where you will be having a tree-like structure, which will be having all internal nodes, which we refer to be as features or attributes of the data. And each branch node represents the outcome. This is internal node. And branch node, which will be the outcome. And leaf node will represent the class label. So the class label will be decision, either yes or no. So we refer that as a classification label. So we have three kinds of nodes. So which is root node, branch node, and leaf node. So when I write a particular tree, so this will be your root node, and this will be your branch node, and this will be your leaf node. So leaf node always will be at the end portion. So once you reach the leaf node means that is the end of the decision tree. That will be your end. Now, coming to build the decision tree is main important factor. How do you build the decision tree? So we have a procedure or notation, or we call it as a decision making parameter based on the gain value. Okay. So first we'll try to split the data into train and test model. So under that we'll be having tree generator determination. So when you're splitting the features, we just need to understand which is root node and which is internal node and which is leaf node. Of course, leaf node will be a class label, either yes or no. It will be like this. Either you play or not play. So that will be your decision. So you can see that from the example, the decision tree, the student is there. If he is a student and if his income is very high and very low and medium. So you have a student column and you'll be having income. So under income, you have high, medium, and low. Okay. And then you have a credit rating with excellent credit rating and fair credit rating. And you'll be having one more column, that is age, which is having greater than 40, 31 to 40, less than or equal to 30. So there are four different. So this is yes and no. So there are four different parameters which is telling whether it is buying a computer or not. Saying yes, and this is no. So these are the class label. Buying computer will be the output based on all these parameters. So when I consider all these parameters, without any calculations, I've taken student as a root node. So when I consider a student as a root node, I'll be having yes or no. And when you have yes or no, you'll be having income. And I've chosen income for the second one. And then you have age and credit rating, age and credit rating. As we move on, you'll land up with the leaf node. When I consider student as a root node, what is the, how many steps you follow to traverse the tree? That means this is one path. If he is not student, his income will be high. If his income is high and the age is between 31 to 40, is going to buy a computer. If he is less than 38, then he will be not buying. So there are two steps here. Now again, if his income is medium and the credit rating is fair and the age is greater than 40, he is going to buy. So this is one path. And this is one path. And this is one path. And this is one path. So this is one path. Like this, you have how many paths? So you need not to worry about calculating the paths. So when you see the leaf node and count it, you'll come to know what is the number of paths. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you'll be finding 11 paths and you'll be finding the 6 steps. 6 parameters like student, income, credit rating, age. At the end, you are supposed to say buys computer or not. So this is okay, fine. We have done by considering the root. But how many steps we are following? 11 steps. 11 traversal. I'm not saying this is wrong. This is correct, but we have more steps. Now, again, I'll consider income as a root node. Okay, so this should be changed. Income. Income is a root node. So then I'll be having age, student, credit rating, age again. So there will be 10 steps or 10 traversal. So you'll be having 10 traversal for the tree when you choose the income. So which is better when I choose student. So when I choose income, that will be better that it got reduced with the traversal. The computation got reduced. So when you are designing an algorithm or when you are choosing the algorithm, it should run with minimum utilization of resources and also within no time. So with it, by using less time. So that computation cost will be reduced and execution time will also reduced. So you can check for the previous tree that it is giving you 10 steps when you consider income as a root node. Now, randomly, I can't pick the value. Hence, I do go with the entropy. And I calculate the value for the same. And for particular data set, I'll be calculating. And the information gain for the given data, I'll be calculating. And at the end, I'll be calculating the information gain of overall data set with the parameter. And I'll be getting gain of that particular attribute or the feature. So with the help of gain value, if it is higher, then we'll say that is an important attribute. If it is lesser when compared to all the other parameters, then it will be discarded. So which is having gain, more gain value. So you are considering that. Now you can say from this table, what you will do, you just calculate the information gain of overall data set. So how do you calculate? What is the formula? So we have a formula, information gain, sigma 1 to m, pi log pi to the base 2. So minus sigma I tends to 1 to m, pi log of pi to the base 2. What is this pi? It is a probability. So how do you calculate this probability? Now, information gain of the Bayes computer. So information gain of Bayes computer. So when I calculate the probability information gain of the overall, you will be having the overall data set where you will be having 14 rows. So we have seen 14 rows, and at the Bayes computer column, in this particular column, this is the output, the information gain of particular data set, you'll be having yes and no. Now, what is the probability of S in this particular column? How do you find the probability? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 columns are there totally. Okay. How many yes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 14, you have 9. Remaining is 5, and it will be. So this will be the probability of yes and probability of no. So when you combine this, you will be getting an information of overall data set. So information of overall is giving us summation of I1 to m pi log of pi to the base 2. So how will you write this particular equation? So we write this as 9 by 14 log of 9 by 14 minus 5 by 14 log of 2 5 by 14. So you'll be getting 0.940. This is important number, which is information gain of the data set. So now you need to select each column under this, under keeping this as a reference. You need to select each column. How many columns we have? So we have age, income, student, credit rating. So we are not considering this because record 1, 2, 3, 4, and we are not also considering this is at output. So we are considering only age, income, student, credit rating. So when I consider age, column, and I need to calculate the information gain of age. Information gain of age. What is the column that consists of? The column consists of 3 parameters. One is under age, you have 3 parameters. One is less than or equal to 30, 31 to 40, and greater than 40. When age is these parameters, you will be having Bayes computer. Bayes computer, that is saying yes and no. So these parameters, when I say less than or equal to 30, how many yes are there? How many no are there? That will give you the probability of less than 30. When I say 31 to 40, if I calculate how many yes are there and how many no are there, then it will give you the probability of this. So the probability of this will be find out how many yes are there, how many no are. So we'll go back and then update the tabular column saying the particular number of updates with respect to the SR. So overall how many yes and overall how many no. So we got to know from that overall positive is 9 and overall negative is 5. So this is 9 and this is 5. So when you add this overall, you will be getting 9, and you add this, you will be getting 5 overall. Okay. So when I divide this, you can see that the space is given for less than or equal to 30, 31 to 40, and greater than 40. So these are the three parameters. So positive and negative, how do you define it? So when I consider only less than or equal to 30, how many positive, how many negative? That means I just need to consider with the table less than or equal to 30. I am considering first one and I am saying positive, negative. I am calculating the probability. So overall is 5 because how did you guess that it is a 5? So sorry. You can see that this is 1, 2, 3, 4 and 5. Hence I have told that there is 5 count. Now under this, for this option, you have no, you have no, and you have no. The other two are yes. So this is saying yes and this is saying yes. Now, how many no's are there? How many yes are there? So no is 3 and yes is 2. So like the same, when you consider what is the next parameter? 31 to 40. When I consider 31 to 40, how many are there? 1, 2, 3, 4. So 4 are there. Out of which one is S, this is S, and this is S, and this is also S. So out of 4, 4 is also S and 0 is no for this and for this. Now greater than 40. So you have one more option that is greater than 40. Now how will you calculate the probability? Greater than 40, 1, 2, 3, 4, 5. So out of 5, how many yes and how many no? So this is yes and this is yes. So I'll list only yes. 1, 2, 3. Okay. So 3 is yes and 2 is no. So you can see that when I calculate this value, you will be getting 9. And when I add this value, you will be getting 5. So 9 plus 5, 14. So you are getting here 14 and 5 plus 9, 5 plus 4 plus 5 is also 14. So this is how you calculate these values 2, 3, 4, 0, 3, 2. And you will apply information gain of that particular attribute, that is age. So you need to calculate information gain value is same. Sigma I tends to 1 tends to m. So pi log of pi 2 to the base 2. So I consider first less than or equal to 30. So I'll be getting 2 out of 5. Don't worry about, don't consider 9. Out of 5, you got 2s. That is 2 by 5 log of 2 by 5 minus 3 by 5 log of 3 by 5. So you'll be having minus here. So you calculate this value and get the value. Now, next, when I consider minus, when I consider 31 to 40, so I'll be having 4 by 4 log of 4 by 4. What is log 1 to the base 2? Log 1 is 0. So you will not get any gain value. So you will not get any gain value. Now, it is easy to understand here. Easy to understand here. When you are having information gain as 0, that means it is not giving any variation. That means 31 to 40 is giving everything is saying yes. So this is also saying yes. This is also saying yes. So this is also saying yes. And this is also saying yes. So there is no variation, that you have only one option, that is yes. So information gain is with respect to the other, but we are not calculating because everything is saying yes. So you can understand from the given information gain. So you don't have any information from 31 to 40. When you have differences, you will have information. Now we'll see greater than 40. How many of total are there? 5. So minus whole divided by 5. That is pi. Out of that, 3 is saying yes. So I'll be having 3 by 5 to the base 2 minus next 2 by 5 log of 2 by. So calculate this value, and when you are calculating, you will be calculating and making a note of it, and at the end you will be adding these summation. So you'll be getting the information of age. So like this, we have calculated for age, and now we consider income. So how many are there? High, medium, and low. So out of 14, how many of them are high with respect to yes and no? So let me write clearly. So high, low, and medium, saying yes and no. So at the end, you should get so here I need to get 14. Okay. So now when it is high, how many yes and how many no? So high is there 1, 2, 3, 4. So it is 4. How many low is there? 1, 2, 3, 4. That is also 4. 4 plus 8. 4 plus 4, 8. Next 1, 2, 3, 4, 5. 6 are there. So can you see that? So 4 plus 4 plus 6 is 14. Now we got it. Among 4, how many are saying yes and how many are saying no? That will give you the probability of high. The probability of high saying no. We just need to concentrate on Bayes computer. That is output. So high, no, high, no, high, yes. And here high, yes. So there are 2 yes and 2 no. With respect to low, so we have 1 yes, 2 yes, and 3 yes. Okay. So 3 and 1. So for medium you have 1 yes, 1 no, and all 3 yes, 2. So 2 and 4. So 1, 2, no, 1, 2, 3, 4. So 4s and 2. So you can see that 2 plus 3 plus 4 is 9. So 2 plus 2 plus 1 is 5. So 9 plus 5 is 14. So we got it. So the calculation is correct. We got the values. Now we need to calculate the information gain of income. So information gain of income will be high plus low plus medium. So what is the high value? Probability of this value? So 2 by 2 log of 2 by 2. So it will be 1 and it will be 0. So no contribution from high. Now we have low. So what is low? 3 and 1. So 3 by 4 to the log of, I'm so sorry that. So you have contribution from high saying that 2 by 4. It will be 2 by 4 log of 2 by 4 minus 2 by 4 log of 2 by 4. This will be again 2. 1 by 2 log of 1 by 2 minus 2 by 2. 2 into 1 by 2 log of 1 by 2. It becomes log of 1 by 2. So you calculate log of 1 by 2, you'll be getting the gain value. So like this, you calculate for low and medium. So once you calculate the low and medium, you will be getting information gain of income. So we have done with information gain of particular attribute, particular values. So we calculated for everything. So information gain of credit rating. So we got some value. The overall information gain of dataset is 0.940. So now we need to calculate what is the next step that we need to calculate. So we need to calculate the gain of particular column. So when I calculate the gain of particular column age, you'll be getting the information of overall data set minus information of age. So what is overall? 0.940. What is age? You'll be getting something 694. You'll be getting 0.246. And see to that it is not increased beyond 1. So you got information gain of age. So like the same, you calculate information gain of income, student, and credit rating. So once you get the values, you will find that information gain of age is bigger and you will try to draw. So when under age, you have 3 categories. What is 31 to 40, less than 30, greater than 40. So less than equal to. So the 3 categories. And after this, you will be having student. If he's a student, because next information gain is student. So when you are considering the left side, student will be there. The right side, next credit rating will be there. So whatever you have left side will be the higher value and the next one will be the lower value, right side or the left side. Now, how many steps you can reach to the leaf node? Age, student, no, and no. So 1, 2, 3, 4, 5. So in 5 steps, we can take our decision by keeping age as a parameter. Now in future, when you want to predict, let's say example, I want to say a person is buying a computer or not based on the some prediction. Let's say example, he is 31 to 40 and he does not have a credit rating. So it is fair enough. So 31 to 40, fair enough. And he is a student. When I say first starting itself 31 to 40, obviously you'll say he buys the computer. So there is nothing like checking with the credit rating and student. So when I start predicting, I'll just go with this. So it will be yes. So when it is less than or equal to 30, you want whether he's a student or credit rating or fair. So when it is student, he'll be saying again yes or no. So like this, in future, you just need to predict it. So now we'll try to understand, this is a decision tree based on the entropy, information gain of particular parameter and information gain of attribute. So this is parameter, individual parameter or features, and this is overall data set, or I can say with respect to output, information gain and the entropy. So this is the idea behind decision tree. Now we'll try to understand what is the particular code and how it will be, and we'll see that. So I've taken the stock price or trade price to predict, to analyze what will be the next. So I've taken the company, Apple company, and the CSV file I've imported, and this is the data that I have, and I'm checking for the shape. So 315.7. So I need to draw the stock price with respect to the close price. This one, the close price, the close one, with respect to the days. Okay, so 2, 3, 4, 7, 8, and it got changed. So my intention is I'll be concentrating on the closing amount, the closing price. The closing price. So from this, we'll try to understand whether it will increase for the next day or decrease. So this is the prediction that you are performing. We also read open, high, low, adjacent, close, and volume. So we'll first decide which is impacting. So this will be your output. All others will be input. So we'll just try to get the information gain of all these and overall data set, and we'll set which is having root node and which is a leaf node and which is the end node. So from this, end node will be increase or decrease. So we have considered the data and we have plotted for the given data. So this is number of days and this is the price. Okay, now so we have considered only the column and we are supposed to predict for the future days. Next 25 days I need to predict. That is a value that I have taken. Now, next, how do you predict? How do you choose it? So from the data that what I have, the closing price, I need to shift next 25 days or the previous 25 days. So first 25 days will be your, or you can say that like this, you have a close price, you'll be having the values. I want to predict the next 25 days. So this will be considering the previous 25 days because based on this only, you will predict the next 25 days. So this will be your minus shift 25 days and this will be your current 25 days, which is prediction. So it will be null values because we don't know the what is filled here. And we are passing the same value, that is prediction value. We are dropping that prediction value. Here you can see that we are dropping the prediction value 0 and 1, and we are completely taking all the minus future days. That means all these. Now, when I consider only those values, and you are considering the output as that particular column, that is prediction column, I've predicted for all the values. not only with respect to the future dates, not only with respect to 25, it has been calculated for all the days. Okay. So now it is good that it has been calculated with the prediction Y. And now with that data, I'll split some portion as training and some portion as testing. Decision making, right? So we classify them and then make a decision. Now I've made it as 25 and 75. Now I'll be using decision tree regressor and fit that train and test. So we got the model tree and it is going to drop this prediction and use this X future, and whatever there in the tail, that is going to be X future, and that is going to shared in the X future. So it is keep on updating with the values. So now it is going to predict and it is going to consider only the future days, that is which are below. So you can see that only these values will be taken from 317, from here 317 till the end. So that is the last 25 days. Okay, so it is considering that. So from 317 to 298. So that will be considered to calculate with the prediction. Now, based on these values, I'll pass that as a prediction. So now decision tree model is tree that is going to predict in future. So whatever I've told you, the calculations of root node, leaf node, and then and all these. So decision tree has made. So after that, I've given you again when 31 to 40, when the age of the particular person is 31 to 40, you said the output will be yes. When age is less than or equal to 30, again it will consider whether he is a student or not and then say yes or no. So I'm predicting either yes or no at the end. So that is what prediction that we are doing it. So now here I've passed that and I've given. So these will be your prediction values for the next 25 days. So this is your predicted values. So I've taken this prediction value for next 25 days and I'll plot this in the graph. So when I plot that in the graph, you can see that adding the original one is this one. So till here, the original. So this is next 25 days. This is prediction. So this will be helpful for the person who is financially looking to invest and do some trade on that particular company. So blue is the original value, orange is valid, and green is prediction. You can see orange and or green are all same on the same. So it is all about the same predictions that you are getting with the values. So this is what important with the help of decision tree, that is classification model. So only that you do required is considering the values and calculating those 25 days values, that is prediction. That is more important. So here you have calculated the next 25 days values and then you are plotting the same with the previous one, original price. So this is how decision tree is helping. So earlier we have used KNN model and now we have seen decision tree. So at the end of the day, we'll see which model is going to be used or which model is suitable, that we can see. Okay. So this is what decision tree, that is classification model. And earlier we have seen KM. So any doubts? So if you have any doubts, please mention the same in the chat box. Okay, there is one question that if the data set is huge, it is taking more computation time to form a tree and then take a decision. Okay, let's say example, you have 2-3 companies. The person will be analyzing, the person is not only looking into one single company, only Apple company. He'll be looking into TCS, he'll be looking into Infosys, he'll be looking into Wipro, he'll be looking into other companies, and he is going to compare which is having more prediction or which is going to give you more price. So when you are doing with single company, you'll be getting a predictions to understand, conclude whether to go with whether to buy with the shares or not. But when we have a multiple, it will take more computational time, and at that time we use random forest, which is again a classification model where you'll be using a different tree. So individual tree, this is one result and this is one result and this is one result, collecting which is best one. So random forest. So it is forest means group of trees, collection of trees, and you randomly pick the trees and then you conclude. So this is what an advanced ensemble technique that will be seen with the help of random forest technique that is required for classification problem. So which will be accurately and within no time, it will give you the particular output to which company you need to invest. And it will conclude what is the best predictions that you are getting for the next 25 days, even for the random forest. So do you have any queries? So if you have any queries, please let me know in the chat box. I'll be going through the questions. Okay, friends, we'll wind up the session now and we'll continue tomorrow, and we'll try to understand how neural network is going to contribute in trade analysis or stock market predictions. Okay, then guys, we'll meet tomorrow. We don't have any questions, so we'll meet tomorrow. Thank you all. Bye. And don't forget to subscribe the channel. You'll be getting more information on domain analytics. So various domains sessions are going on. So please do subscribe and get the information on various platform and domain. And also we are looking into the Python session. So don't miss the opportunity to learn Python language, which is very basic for machine learning, data science. So try to be active in the online platform. Please update whatever you are learning, and hope it will help. It will help for your career. Thank you all. Have a nice day. Bye.